Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, welcome back. So for this problem, we are pulling out a tree stump, and we have two force vectors to represent how we are doing this. Just draw a coordinate plane here. All right, so the first vector goes along this south axis right here, and it has a magnitude of 3,160 newtons. Actually, this is in the problem. We're given that it's the second vector, so I'll label it the second force vector, f of b. The first one is a vector that goes about in this direction, forms an angle of 34 degrees with the x-axis, so 34 degrees south of east, and it has a magnitude of, I guess we should denote that this is magnitude we're talking about here. This is a magnitude of 2,240 newtons. All right, so we want to find the magnitude and direction of the resultant vector. That will be something like that. All right, so to do that, we can split each of these vectors into their component parts, add those component parts up, and to create this new resultant vector right here. So f sub b is already actually in its component parts. It just has a y component of magnitude 3,160. F sub a, we can find its component parts as follows. So we know that we want to find the x component. We want to take the cosine of 34 degrees and multiply that by 2,240 newtons, because that'll give us, that'll scale this up to be the right size here, right here. And that will give us a component which is equal to 1,857 newtons. We're going to do something very similar for the y component. You want to scale it by that, 2,240 newtons. This time we're going to take the sine of 34 degrees. That'll give us 4,413 newtons. I'm going to put a minus sign right here, just because this is in the minus y direction. I guess I should put it right here too, because this is, well, actually no, that's the magnitude we're talking about there. However, this is in the minus direction too, right here. All right, so now we can add up the components right here. So the total x components of the resultant vector, I'll do that in green. The x component, oops, we'll try that again. The x component of this resulting vector is going to just be this value right here, because the f sub b doesn't add anything to the x component. All right, the y component is going to be a negative 4,413 newtons plus a negative 3,160 newtons. Because like I said, this vector right here is in the negative direction, right? All right, and when we add those together, we get that they are equal to excuse me, I did something wrong here. I just realized that. So Oops. That was not what that was equal to. This is right here. It's equal to negative, whoa, is equal to negative 1,253 newtons. That'll change our answers right here. Sorry if that was confusing before. You didn't understand where I was pulling out these numbers. All right. Oops, I erased the wrong number there. 1,253. This is 3,160. And it is going to be equal to 4,413 newtons. There we go. Sorry if that was confusing before. All right, so to find the total magnitude of this vector, which I'll just call F sub r for resultant, magnitude of this vector is going to be equal to, if we're using Pythagorean theorem, 4,413 squared plus the x component squared, so 1,857 squared, which, if you do the math there, put it into your calculator, you'll find that it is 4,788 newtons. To find the direction, we can use, we'll square the, put a box around the answer there. The angle theta, which is this angle right here, the angle of the resultant vector, is going to be equal to arctangent of the side opposite. So this is going to start getting a little messy over here. So if you kind of create a line right there, form this triangle right here, then it is the side opposite of the angle, which is equal to 413 over the x component, which is 1,857. Again, these are newtons. Which that is going to equal 67.2 degrees south of the east axis. And there you have it.